On into lesson 7 of unit 1. As in our last lesson, we were just looking at how to solve quadratic equations. We're now looking in this lesson on how to graph a quadratic. So again, this is still under the Algebra 1 umbrella. I know you guys have seen this for the last few years in other math courses, so this should be a review for you. But apart from reviewing with you how to do these by hand, I'm also going to show you how you can take advantage of your calculator as well. So make sure you, if you're watching the video, have that handy so you can do a little practice on there with me as we get to that. But let me show you first how we would do a few things by hand. It's really important that you never rely too heavily on your calculator. There's always going to be cases where they present questions to you in such a way as where you got to do some stuff by hand. So it's really important that you know how to do both. So if we have this equation right here to graph, so we got the 2x squared minus 6x plus 1. One of the first things that we can do is, working with this formula right here, we can find our axis of symmetry. Now this formula is in your formula packet. It's kind of one of those things that often goes overlooked, but it is in there, so don't forget about this guy. The axis of symmetry is an imaginary vertical line that runs right down the center of your graph. And so that's what we're going to start with, is finding that center line of the graph. And so if we do negative b over 2a, so in this case, if this represents a, b, c, we're going to do negative b over 2 times a. And so here's what that setup would look like for you. And if you clean that up a little bit, we can get it down to 3/2 or 1.5. Same thing. So you could write it either way. I tend to write it as a decimal just because it tends to be easier to put onto the graph if you see it as 1.5 instead of 3/2. People seem to be able to find this a little easier on the grid. And so we're going to call that x equals 1.5. Take note that if you're ever asked to write down the axis of symmetry, the axis of symmetry is a line. It's a vertical line, and so you have to write it as an equation. You have to say x equals 1.5 and write it as the equation of a vertical line. If you just put 1.5, you'd be marked off for that. So that's kind of the first step on this. We got the center line of our graph right there, that imaginary vertical line. The next step is to find the vertex. And so the vertex, which is going to be this point down here, is always on the center line. It's always on the axis of symmetry. So whatever the x-coordinate is of that axis of symmetry, it is also the x-coordinate of our vertex. And so we're going to take that 1.5, we're going to sub it in for x right here and right here so that we can get the y-coordinate to go with them. And so if you plugged in the 1.5 into your x's, you're going to come out with negative 3.5 as the y-coordinate of your vertex. And so now we can plot that point on the graph. So right there we have our vertex of the graph. Two things you should always know about the vertex of a graph. As we already stated, the x-coordinate is your axis of symmetry. The y-coordinate is always the max or min of the graph. It's just a y-coordinate. So whenever they ask you for a max or a min, that is always reference to the y-coordinate of your vertex. In this case, because our a value is positive, that means the graph is going up, which means the vertex is the lowest point on the graph. And so in this case, we have a minimum, not a maximum. And so if we were asked what the max or min was, we would say the minimum is negative 3.5. Third step is, now that we have the center line of the graph and the vertex, we just need to come up with a point or two on one side of the graph, and then we can just mirror that point onto the other side to come up with a sketch of this graph. So one point that we can always find pretty easily is the y-intercept. Anytime you want to find a y-intercept, we just plug in a 0 for x. So if I put a 0 here and a 0 here, I'm left with 1 as my y-intercept. And so we're going to plot that point 0, 1, and then just mirror him over to the other side. All right, so right here, if this is 1.5 units away from the axis of symmetry, then I'm just going to go another 1.5 units over here and plot the other point that would go on the other side. And that's enough for us to at least get a decent sketch of this graph. But those are some basic steps that you should always know how to do by hand. I'm going to show you the calculator right now, and so let's get into that. You will be asked at times for the domain and range of any graph. And so if you look at this one, domain and rangers, they're always easier to identify once the graph is done. And so now if you look at the graph, domain we know is always whatever your graph is doing from left to right. Domain always represents the x values of any graph. And so what is this graph doing left and right? Well, this is going to continue going out this way forever. It's also going to continue going to the right forever. And so this graph, we would just say for the domain, is all real numbers. So this graph would go from negative infinity to positive infinity as far as the domain goes. The range is what your graph is doing up and down. So the range is always affected by the y-coordinates of your graph. And you can see that the lowest point on this graph is negative 3.5. And from there, it's going to go up forever. So we would say, one way of writing this would be to say, as an inequality, the range is y is greater than or equal to negative 3.5. And so that would be one way to identify the range of this graph. So let's take a look at some calculator stuff for this. So I'm going to take this function and I'm going to plug it into my calculator so we can look at the graph for this. So if you go into your y equals and you plug in the function that we're working with, so I already put it in there for you, just so I can get right to it. Once we enter in the function, again, if we just go over here and hit graph, then we get the graph. There will be times where this graph may not fit on your screen. It might be up here or over here or down here, and so you may have to adjust the window settings of your graph. So let me just mention that really quick. But if you go into window, this is how you interpret all this information that you see here. The x min and the x max are how far you want to see on your graph from left to right. So my graph right now goes as far left as negative 10 and as far right as positive 10. And I'm just using a scale of 1, so my calculator is counting by ones. And I pretty much always just keep the scale as 1. That really doesn't affect you much. But this is what we're seeing from left to right. And the y min and the y max is what you're seeing from bottom to top. And so this is the lowest I'm seeing on the grid is negative 10, and the highest I'm seeing on the grid is positive 10. So if I ever needed to see more, like if my graph is way up here or way down here or way to the left, these are the settings that I can adjust to see more of my graph. And so if I need to see farther to the left, then instead of negative 10, I might do something like negative 20. And so I can see farther to the left. And if I make this guy bigger, I can see farther to the right. This is farther down and farther up, the more I make those bigger those numbers. So these are the numbers you would always adjust if you ever need to see more of your graph. So let me go back to the graph, and here's a couple things you can take advantage of on your calculator. Once you've graphed it, if you need to find the vertex of your graph, again, we know the vertex in this case is the lowest point on the graph. And so if I go under calc, so second calc, and I choose minimum, this is going to help me find the vertex of the graph. And so I'm going to hit enter on that. They're going to ask me a couple questions. Now we know that the vertex is right about here. So they want me to establish some boundary lines. So if they say the left boundary, well, I'm going to go left a couple times. Right about there. It doesn't matter where. I just need to be left of my vertex and hit enter. And then it's going to ask me for a right boundary. So I'm going to go right a couple times. Just need to be to the right of my vertex and hit enter. So you can see the boundary lines that they set in. And now basically what your calculator is going to do is it's going to find the minimum value within that little window. And so that's going to be the vertex that we're looking for. So whenever they say guess, just hit enter. And there you go. We have, now we would see that as 1.5 and negative 3.5, which is the same vertex that we got when we did this with the negative b over 2a. So we're good on that. We got the vertex, 1.5 and negative 3.5. So that's one of the features you can take advantage of. The other one is this, and this is huge. You see right here where it says table. So if I hit second table, I can get every point on that graph. So if I have to sketch any points or sketch the graph, or any value I need is on this table, and I can go up and down forever, but these are all points on my graph. So you can see all those points right there on my graph. So if I needed to sketch a graph, all I would have to do is find some reasonable numbers. If you look right within this little area right here that I'm highlighting right now, those are pretty easy to graph. Those are reasonable numbers. Obviously, I don't want to use ones like that big, 109, so I'm trying to stick with ones that would make for easy graphing. And so I'm going to use kind of the smaller numbers that I see here on my table to sketch my graph. And so that's something else you can take advantage of on the calculator, is the table feature that we have. And so those are good things to take advantage of. Pretty much it for this. Whenever we're doing graphs, though, we got to make sure that we're doing these on graph paper. Accuracy is important, so we got to make sure that we're using graph paper and shooting for accuracy on this. There is some review of your calculator usage on page 201 of your book, so if you do need to look at that, you can, but I think I covered pretty much what you would need to know here in this video. So